I'm pleased to be here, and hello and welcome everyone. So I'll be talking about our journey with Symphony AI and how we use it and what kind of benefits we basically reaped over a period of time and what were the challenges that we faced. But before that, a brief introduction about myself. I'm a mechanical engineer by degree, but I never used it, never worked in mechanical engineering. Also, always started my career in IT. So have 17 plus years of experience in IT, but that is inclusive of my data science ML experience, which is 10 plus years of experience. So though when I use my data science ML experience, I do use mechanical engineering because a lot of our my work is related to the sensor data, and and with that, last 4 years mostly working in the predictive maintenance technology. With that, I'll just move forward and talk about a little bit about my company. So, uh, Novelis is it's a leader in the flat rolled aluminum and recycling. It has roughly 13,000 employees present in 9 countries and has 32 plants worldwide. And we roll annually like roughly 3,600, 3,700 KT of rolled aluminum. So the most of our customers are based in so we have 4 segments: beverage, automotive, aerospace, and specialty. Now we are really big in beverage industry. So anytime you are drinking a soda can or a water can, which is made up of aluminum, 60% chances are that it is processed by Novelis aluminum. Uh, Novelis aluminum goes into roughly like 300 car models, and we recently got into aerospace and specialty. Now, in terms of just to understand the problem that we were facing, because we have 32 plants, the problem that we were facing was production delays because we were getting unplanned downtimes because of machine failures. And just to give you a little bit context around those 32 plants, they were not like started in the same time the year. We grew with the acquisition. So some plants are like really old 1960s, some plants are 1980s, some plants are really new. We are building a new plant in Alabama recently. So there's like all the different, you can just think about all the different enterprise layers that you can think about. We have all of that. So at one plant we are running Oracle, other plant we are running SAP, one other plant we are running Maximo. So we have all of it. So that kind of helps you give like perspective and why something like a unified platform was important for the company where we have so many different data sources. Now, with these production delays, we had the impact of production delays was the customer dissatisfaction, because if we have the delays, then we are not able to fulfill the demand on time and in full. So that was one of the biggest problem. Another problem was increased cost. So anytime there is a breakdown, there is a repair cost, and also there is a emergency cost. Like entire plant, all the people, they are working on fixing the problem because they want to make sure that the plant is up, back, and running. So if all the people are working on fixing the plant, then they are delaying some other processes. So that was very important, that these 3 points were very important for Novelis, and these were the main problem areas. And so the easiest solution for us was basically start doing the real-time monitoring as well as doing the predictive maintenance. So before doing the predictive maintenance, what we were doing was preventative maintenance. So if I talk about one of our plant, so in our plant, we have like bunch of machineries. We have hot mills, we have cold mills, we have cash lines, we have recycling centers. Now each machine center would be shut down for once a day, once in a week for 8 hours. And we'll just go fix it, do everything on it, and then just bring it up back running at 5 o'clock in the evening. So we do that. So that was the reason, like we wanted to, and we always had this issue of, meeting the demand, because the demand was more and the supply was less. And so we wanted to make sure that we are more productive. And so one way to get more productive was to have like predictive maintenance and stop having the preventative maintenance. And so with predictive maintenance, we started thinking about like what are the solutions we have in the market. So we started this journey in 2021. We started looking out at different competitors in the market who provide preventive predictive maintenance solution. And the reason why Symphony stood out was it was providing a holistic solution. It had both the rule-based alerts as well as AI ML-based alerts. And both are powerful because when you are starting in a plant, you have like PhD engineers, they have like masters, bachelor's engineers, right? They're very smart. Now, if you just move them from what they are doing currently to all the way to AI, which is like kind of black box and spitting out the anomalies, it's very hard to basically convince them to start using it. So we took a step down approach, or maybe call it a stepped up approach, wherein like, maybe start with the rule base first, and then bring them to the ML based alerts. And another reason why we wanted both the solutions was because let's say if we are getting both the alerts together for a particular asset, let's say on the drivetrain side, let's say if we talk about the gearbox, we have one alert from the rule-based side and the same alert for the same asset, we have alert from the anomaly side or the ML-based side, then we have very high confidence in it. So we reduce the false positive rate from that. So that was the reason why we were looking for a holistic solution. The second reason was experience with a complex machine. At that point, when we started taking the customer feedback from the other customers of Symphony, we figured it out that they have experience in the rolling machines. And that's where we wanted our application to be deployed. And the final was a unified platform, and that is very important because we wanted one platform where all the like data engineers are also part of it, data scientists are part of it, reliability engineers are part of it, automation engineers and the process engineers. And that is important because if all these people are not working together, you will not get the value out of it. So to get the value out of it, you have to build that ecosystem where all these people are working hand in hand and sharing the knowledge and creating the value. So that was the reason why we chose Symphony in 2021. And just to give you the overview of the solution, and let me build up the entire slide. Again, I want to stress, specified very clearly, like the reason why we chose is it had the connectors from all the different sources. We are really big on historians. We use IBA and Pi systems. So we could easily connect our historians with the application. And the second reason it was important was the thermodynamic physics rule-based alerts at the same time ML NLP-based alerts. So we could combine that. And the final reason, which is important, was that anomaly cause engine, which is like connecting your alerts with FMEA and then showing the cause, like what are the actions the reliability engineer will take. Because if alerts are generated and your reliability engineers don't know what to do, then that's also a problem. So they should have a flow chart. They should have a steps to take and move forward and take action. And not just that, this platform had another very good feature was the feedback. Let's say you get a false positive, you can just provide the feedback that goes back into the machine learning model, and then next time you don't get the same false positive rate. So that was the reason like this solution stood out that time. Moving forward, still building. Okay. Initial challenges. Some of the challenges were like maybe before selecting the product or the application or the vendor, like picking up the right machine, like where do you want to deploy your predictive maintenance. So you have to strategically find out which plant makes sense. Where do you have more sensors? Where do you have the data, the curated data, or maybe the clean data? Where there are people who have like enough bandwidth to support it, because a lot of times it happens that you start a project in the plant and they do not have the bandwidth to support it. And we faced that a lot in the past. So data availability and the resource, that's very important to begin this project. And the second is change management, which is like, once you start building the models, you have to identify the leaders within the plant, like, who is going to take that flag and, start marketing your solution within the plant so that people start adopting it. They start believing into the solution. And also not just like, you need the cheerleaders over there in the plant. At the same time, you need the processes. Like a rule has been like an alert has been generated. Now, what action? Who will take the action? Is it the electrical engineer? Is it the mechanical engineer? Is it the automation engineer? Who will take the action? So you need to create that process chart or a flow chart where people can go and look at it. Okay, here is the alert generated. It is assigned to maybe this mechanical engineer. Now that mechanical engineer will do these 5 steps, and after that, once it'll come back and click on the system, it'll go and create the work order. So it has to be connected to your CMMI system so that you can create or you can create the work order directly, so that you can also calculate like how much value you're creating in the end. So the more number of work orders you're creating from this system, that means you're creating more value from this system. So that is one way you can identify like what is the benefit that you're getting from this system. Some of the other factors on change management, trust in the application, it will take some time. Start with rule-based, bring people onto the rule-based first and then move them to the ML-based. Bringing them directly to the ML-based might not work out. So take a step-by-step approach. Quick wins, there are some assets where you can very quickly show the values with the rule-based alerts. Go with the rule-based alerts, show the quick value, and then move on. So that way people start trusting the system, and that is very important. Otherwise, people will not stop using it. They will use it for 5 months, 6 months, and then they'll stop using it. So ultimately, you just remove that system. Now, in terms of benefits, I don't want to talk about any other question.
I have one question.
Yeah.
So it sounds like you took this like top-down approach, right? You led the data science team to work with the plant and persuade the production leaders to try that out, right? And then you had the scientists, data science, to build a model and then test that and retrain it, go through the whole thing. And also for the plant side, you focus on the change management, right? To teach the people how to use the tool, interact with the model and things like that. Did you actually also try to like see if you want to empower the local plant people so that they can build their own model,
Yes.
that way?
Yes, and that is very important because in the end you have a limited data scientist. So you want someone from the reliability engineers, maybe the leader of the reliability engineer who is the leader for that machine center. You want to offload those duty to them. Now again, retraining of a model is again a skill set. Depends on how complex it is. Are you adding new features to that? Are you reducing some of or removing some of the features from the existing model? If that is the case, they'll come back to the data scientist. But if it's just a regular retraining, like, it's 3 months, your data distribution has shifted, it's just a normal retraining, you just go ahead and click the button and retrains, they can do it. But if it is a little bit complex, the accuracy levels or the precision levels are going down, they'll just come back, they will come back to the data science, COE data science team, and then we'll go and help them. But yeah, the idea is to offload this as much as possible to the plant so that they can take it over.
So did you restrict the hierarchy of who can see what according to the senior guy, or did you share everything?
So there were like bunch of different security groups. We created at the plant level. So plant level, let's say plant manager can see all the like hot mill, cold mill, all. Then at the second level, which is at the machine center level, which is like, let's say, hot mill leader can only see all the alerts related to the hot mill, for example. And then within hot mill, you have to see what works for your company, right? So, right. And data governance is a whole different story. So.
So Chirag, I'll ask you a question. I know there are a lot of questions out there as well. Thanks for being that proponent of our technology. We appreciate that. Of course, this is focused on predictive maintenance. Without sharing your intellectual property, all the future planning you have, how are you trying to evolve from the predictive maintenance to more reliability-centered maintenance or outcome-based approach? And then adding on to that, the technology was displayed this afternoon. How are those new capabilities that we brought in could potentially be helpful in drawing more value out of these new activities?
Sure. So there are two questions. So let me answer the first question, which is how do we move forward? How do we automate this process more and more, right? How can we do that? So we are already taking that approach. We have integrated Symphony platform with our CMMI system. And anytime where we have a higher confidence level on the alerts, that alert automatically goes and creates an work order in SAP system directly. So there is no manual person. So there is like a kind of cutoff created, like 85% and more. You just go ahead and create the work order directly, and then from there, the plant team already have their own schedule. Like how do they deal with those work orders? So that is one layer of automation. Now the next layer of automation is from there, like you just go and do the inventory management as well. Like okay, the alert is for your motor. Maybe motor, the brush has worn off, you have to replace the brush in the motor. Now you look at the inventory directly because the work order is created to replace the brush. You look at the inventory, or there are no brush. It sends the order to the brush vendor. They'll send it back, and then you can probably create a maintenance schedule that, okay, it's going to take 2 days from the vendor to get it back, and you create the maintenance schedule for maybe 3 days down the line. So that's the level of automation that we are trying to create, and it will take time. All what I'm talking about here, it's like just 2 lines, but it's going to take probably more than a year, maybe 2 years.
It's a journey, right?
Yes. And the second question around the new technologies. So when we're using Symphony AI, but our subscription doesn't have that generative AI capabilities, and that is very useful, very powerful. And the reason why I say is because at this point we have the set recommendations for the engineers. Like we have to write the recommendations for them based on the FMEA. But let's say if we have a generative AI capabilities, then it can create those graphs. And let's say if there are some kind of some cases where there is a deviation, the set recommendations are not working. In that case, you can go and use generative AI and say, okay, maybe let's see what generative AI is saying. What are the recommendations it is giving? So you then start using those recommendations. So this is very powerful tool. We don't have it, we want to use it.
So that's a different price tier, is that right?
I think so. I think in 2021, it was not there. Like, so generative AI itself came in November 2022. Like that's the time when ChatGPT was launched. So we did not have in the subscription, unfortunately.
So Chirag, you one other question I'll ask, and then thank you very much for presenting. You mentioned about IPA, you mentioned about SAP, IBM Maximo and such. I'm sure you're taking the data together, you're trying to contextualize it, trying to connect the dots. I mean, now with this presentation that the team gave on the contextualization, data transformation, making it as automated as possible, apply AI to, really draw the connections more automated than human involved. What's your take on that?
So we have taken a different approach here. So what we are doing is we are not directly connecting Symphony application with these systems directly. So we have a data engineering team. What they do is they basically pull the data from all these different sources, different sites, different plants to the data lake. And then we have connected Symphony system to the data lake. So that way we make sure that the curated data is fed into the Symphony platform. So that's one way to do it. But what you showed today, I think that's another way. Like let's say you do not have that team to do it, and you want to do it, right? So then you can, that's where this application is very useful, where you can directly go and connect it to different sources. And you need to connect it because you need to know that, okay, when is the last maintenance done for the motor? When is the last maintenance done for your gearbox? So that you know that, okay, maybe it's a regular maintenance or there is something wrong with your system. So that is important, that all these data sources need to be connected and then used together as a to create or to generate the analytics.
Awesome. Any other questions for Chirag? Otherwise, Chirag, thank you so much for coming all the way, and
Thank you.